as our first keynote speaker of the day, I am going to introduce Einat from Treeverse, and she's going to talk about DataOps and why it is so hard. So let me share that. And we have, yes. So DataOps, why is that so hard?
Well, I'll explain in details in a minute, but it's the data. The data makes it so hard. And we will see why it makes it so hard when you run this video. Hi, everyone, and thank you for having me. And I'm really excited to be the one opening the community summit. And really honored to be here. I hope to hear your questions after the talk.
Cool. Yeah, so we'll definitely do the questions after the talk. So Einat, could you maybe introduce us to your background and history, and how did you came out to found Treeverse?
Treeverse. So
Treeverse.
yeah, odd name, I know. We thought we were really very.
I'm always getting my wrong, so.
So we were working at SimilarWeb, which is a company with a great R&D and a very interesting DevOps challenges. And there are a lot of challenges at SimilarWeb around data. And we found that we were patching a lot of things because there was no conceptual solution to the problems that we had with data infrastructure. And then when it was time to move on, and then my co-founder, Oz Katz, and myself thought that introducing a solution that might assist in managing data is something that we can do and want to do because of our history at SimilarWeb. Originally, I'm a mathematician, and therefore I also understand data science people and their needs. And of course, they are an important part of the teams that are being served by the data infrastructure and the data DevOps. So it helped me understand the field and connect to the potential customers.
Yeah, it's always awesome when the founder feels the pain before solving the problem. So we're going to move on to the main keynote, and I'm going to share the talk now, and then we'll switch off back to continuing our discussion and have some questions also from the floor.
Hi, everyone. I'm excited to open the first ever Community Summit Tel Aviv with a talk about DataOps. Why is it so hard? So first, a little about myself. So to be honest, I am not an ops person. I am a mathematician. I had my PhD done in Tel Aviv University ages ago. And since then, I have led R&D organizations in startup companies. The latest was a CTO role in SimilarWeb, which is a data company. And of course, whenever I developed algorithms, I extensively used data. And now I am a co-creator of an open source data infrastructure tool called LakeFS that we will mention in a word during this talk. Let's begin. So what are we going to talk about? So if we want to talk about why DataOps is hard, we should probably first define what DataOps is. After we do that, we will talk about why it is hard. We'll talk about data architecture. We'll talk about the roles that people need to take in order to implement a good data environment. We'll talk about data pipelines, whether those are paths or cattles. And at the end, we would look at a few tools that might be the light at the end of the tunnel and solve some of our problems. If we have time, I'm sure we will. We'll have some Q&A. Okay, so what is DataOps? I've looked at some of the definitions and I kind of created my own, but it is really based on what's out there on the web. So DataOps is a collection of technical practices, workflows, cultural norms, and architectural patterns that enable rapid innovation and experimentation, very important when you have research, resilience and high quality, monitoring and fast recovery once we're in production, and of course, collaboration across a complex array of people, technologies, and environments. So what we actually see here is that we already have terms for those challenges. that we already know from the ops world. So creating an experimentation environment is the development environment we're expected to do whenever we provide ops to engineering. Resilience and high quality is our CI/CD, testing platforms, staging environments, and the monitoring is fast recovery is, of course, monitoring and fast recovery. And since ops is a team that has a lot of interfaces, a complex array of people that we need to work with is actually a regular challenge within the ops world. So why is DataOps different than ops? Well, it's the data. So we have another aspect and another challenge above managing the ops, which is managing the data itself. The fact we have this additional aspect not only brings another aspect, but also makes the other aspects that we are used to and know from ops to be more complex. Let's go over this and see how. So why is it so hard? The first aspect is the data architecture. What we can see is that there are no best practices. This is a data lake architecture, an extremely general one. If you have a data architecture or about to build one, you're not necessarily going to have all these components, but you're going to have some of them. Let's go a little into the details for those of you who are not familiar with data applications, because we would need this understanding later in the talk. So on the left-hand side, we can see data sources. Those could be events data streams, actually ingest infrastructure such as Flink or Kafka or Spark Streaming, if you heard the names, and operational data that is usually databases replication into an object storage or a data lake or a single source of truth, whatever we choose to call it. If we look at the bottom, we can see a set of processing techniques such as Spark and Presto that also need orchestration tools such as Airflow and capabilities of accessing the data through SQL such as Hive. This is, generally speaking, the Hadoop ecosystem. What we can see on top is the analytics databases. Once upon a time, that was the only component a data architecture used to have. This is not necessarily now a relational database, but the logic of a relational database, which means it presents tabular data in a way that could be queried by analysts using SQL. And we have a set of technologies today that allow that. In some of them, the deep storage is actually the object store. And on the right-hand side, we have data visualization tools, what used to be called BI tools, such as Tableau or Looker, that can either communicate directly with the storage or can work over an analytics engine. And the last part we have is data exploration. Those are notebooks that are used by researchers in order to develop models over the data. So if you have a data architecture, you would have a subset of what we're seeing here. You won't necessarily have an object stories, you won't necessarily have events data, but you would be choosing your own part of this piece. And when you do that, you would notice that those tools that are presented here overlap in their capabilities. So if we go one level down, there's no real good practice on how to choose which tools are optimal for your own challenge. The ecosystem is based on open source tools. Some of them, or most of them today, have provided managed services, which can take some of the offload of the ops effort, if, of course, you can afford the services provided. But this poses another challenge. Why is that a challenge? Because we have very strong players. We can see here we're talking about AWS, Confluent, Databricks, and Snowflake. 4 very strong players with completely different agendas. The only thing they have in common is a philosophy of conquering all. So AWS would like you to have your entire data pipeline on AWS using their own hosting. Confluent would tell you managing Kafka in real time, would tell you you don't need storage. There's no such thing as batch. You can do everything in real time. Databricks would tell you the entire world is Spark, and Snowflake would tell you run your Spark over Snowflake, which is actually a data warehouse. And each and every one of them is actually pooling the open source, or in Snowflake case, the closed source that they're managing, to their own philosophy, hurting the compatibility that does exist because the tools are naturally open source tools, but somehow the compatibility is now limited. Let's dive a little deeper into that. So when we think about managing data, where we have those different layers. We have the storage where the data is saved. We have the format over it, which is how we save the data and how it is indexed. We have the data frame within the compute application, which is how it is saved in the memory of the compute system. And then we have the compute systems that are running. This is, of course, a very, it's an approximation that only helps us understand that any mismatch in these layers could be a mismatch in trying and work with different tools together in the data environment. So you can work, but when you need throughput and performance, you might find yourself with a lack of compatibility that allows you to get the right throughput and the right performance over several tools in parallel. Another best practice that is very hard to implement in data environments is the development environment and CI/CD, which are critical for creating a resilient environment and high quality output. We will talk later about why it is so complex to create, but since it is a best practice to have development environment and CI/CD, we are mentioning this in this part. The second challenge that we have mentioned in the agenda is regarded to who's doing what, whose role is it to do what, and in data it is a little more complicated than usual. Let's see why. Okay, so the first challenge is who is going to give us the requirements. In regular software application, we have a product manager that works together with an R&D team using agile methodologies, and it is the role of the product manager to bring the requirements and to make sure that the fit between the business, the customer, and the technology is actually met. Data applications, more often than not, are internal applications that serve the organization and the stakeholders within the organization who needs insights about the business. In that case, there is no product manager, or it's not intuitive to some organizations to put a product manager in that position, and hence we are missing requirements. We can miss performance requirements, we can miss accuracy requirements that are critical in order to understand how to manage the data. We don't always understand the business logic behind the queries that are running in the data environments or what they mean to the business. And we don't have a budget or a demand for a certain cost effectiveness. How much does it cost us to get to a certain accuracy, and whether it is something that we want to do or money that we want to spend. So we're kind of in the dark, in a lot of gray areas, taking a lot of considerations without clarity on their influence on the results that we have and on the goal that we are meant to provide the organization. Another challenge that we have in roles is related to a very old and important role called a DBA. So once upon a time, when our data environment was just a great Postgres database running on one machine and providing the organization with all the data that it needed because the data was still small. We had the ops running the machine. We had the users, whether they were analysts, data scientists, or engineers, querying the data. And we had a DBA. We had a person whose role was to make sure the internals of the database, whether it's indexing, schema, or configuration, actually optimizes the data querying that were provided by the users. Today, we are not in the comfort of the relational database world, but rather in a more complex environment. So as data grew, we found ourselves managing a lot of distributed systems, whether it is the storage itself, if you chose to manage it yourself, or if it also all those applications that I mentioned earlier that run over the data, such as Spark, Kafka, or Presto, all of those, or of course, non-SQL databases, all of those are distributed systems that query the data. We still have the engineers or the users that, or the data scientists that query the data. We still have the ops running those clusters, but we no longer have that person in the middle who understands how indexing, formats, and configuration of those environments influences the type of queries or code that we run within those environments. And this is actually something that we fill in as we go along. So server developers who started creating data environments suddenly found themselves the DBAs of a complex set of complex systems. In other cases, it's the ops people who found themselves needing also to become the DBA of those environments. The title for this has not yet been finalized, but in the last, I'd say, couple of years, organizations are more aware this function is missing, and they are trying to build the knowledge and to create the capabilities. If you are a small organization and you're just going into this, you probably don't have the knowledge. So to sum it up, we have a missing link here that connects the capabilities or the configurations of those distributed systems with the querying needs of the company. Right now, if we ask whose role is it, in some organizations, data engineers take this role. In other organizations, DataOps take the role, or data infrastructure teams take the role. It is very important just to note that someone has to take this role because it's very critical for the success of a data environment. So, data pipelines, are they a pet or a cattle? It is a pet. It is a pet because there's one machine running this database. It is a mission-critical database, and we nurture it and we make sure it's very stable. On the other hand, for example, a NoSQL database that runs on a cluster is a cattle because if one of the machines falls, we simply replace it by another one, and until we do that, the cluster knows how to handle itself without the missing machine. So let's look at this data pipeline example. If we talk about Kafka or Spark, or in many cases, the analytical database itself, and of course the storage, those are cattles. Those are environments that are distributed systems with the capabilities of a cattle. But when we want to run another version of our production data environment, we're not looking at a machine that is running part of the Kafka cluster. We are actually looking at duplicating this entire pipeline and running it in parallel. What we want to have is the ability to spin up the entire pipeline, run an experiment on some of the code, and hence we need to spin up a variety of distributed systems, either managed by us or managed by others, and we want to do that efficiently. So this is an ops challenge that you all know, but it does grow and becomes more complex because the systems that are actually creating our production pipeline are complex systems. But this is not the only complexity that we are adding to the world. We also need to manage the data. And data also have the characteristic of being production data. So where do we hold this production data? We either hold it in an object storage. This is what modern architectures do, due to the cost effectiveness and high throughput of object storages. But definitely we can find the need and save the data in a database. A lot of organizations save the data in several places according to the need. And the production data is the data which is the single source of truth that we want people to consume and trust. And hence we guard it the way we guard any other component of production. And it means that if we want to duplicate our data pipelines, we also need a way to duplicate, not necessarily physically, the data that is running over it. In the world of databases, this is solved by creating a replication of the database. We are actually physically replicating the data. In the world of object storages, we can also do that replication, but because object storages don't provide the guarantees given by databases, this could be a bit dangerous. So let's dive into the object storages because they are a main component in every data architecture. And understand, although I highly recommend using, of course, an object storage, what we need to be careful of. So there is low visibility and manual management of this environment. It doesn't help you efficiently manage or create resilient work because it's a shared folder in the logical management of it. It is immutable. It means we can replace data by other data or a file by another file, but not necessarily change it. There is no transactionality. There's no guarantee of transactionality, which goes very well with no cross-collection consistency. And hence, if we want isolation, if we want to be working on our own copy of the data, or we want a duplication of our data pipeline to be working on its own copy of the data, we need to copy the data. But if you we create a lot of copies in a manual managed environment, clearly this is an error-prone situation. And there is a lot of attention to that fact in the last few years, or a growing attention. Part of the reason this is getting more attention now is that problems like performance and throughput of data infrastructure were solved or are sufficient to most organizations, and manageability became now the biggest challenge. So what we could see on the left-hand side is a set of tools for MLOps, or in the MLOps world, that provide solutions for people who actually manage and create ML models. So we're looking at one application that allows replication of pipelines and versioning of data to allow efficient work for data scientists who build ML models. So that is nice, but we do with the data a lot more than just ML models. So this solves only part of the problem. What we see on the right-hand side are solutions that aim towards giving the data itself characteristics that would help manage it no matter what the application is. On the top, we see data formats that run within the object storage and allows the object storage to provide mutability through those formats and also time travel within a table, which is helpful for manageability and for recovering from errors. And on the bottom, we see tools that actually allow you Git-like operations over your object storage. So if now you have several versions, or you can spin up another data pipeline from an ops perspective, you can simply open a branch of the data and run this pipeline over a branch of the data, providing a full isolated data pipeline for experimentation. So this helps solve both parts of the puzzle. To sum it up, so DataOps is actually DevOps for data, and as we said, it is more complex because of the aspect of the data that not only brings complexity by itself, but also makes other aspects complex, of course, if you have big data. On the ops side, we see a lot of work being done in the last 10 years to improve the situation, including very strong players that bring viable solutions. And on the data aspect, there are now emerging tools that are helping you build resilient data pipelines and duplicate data pipelines for experimentation. LakeFS, the project that I am a co-creator of, is one of those examples. So check it out, show us some love, and give us a GitHub star. Thank you very much.
Oh, I was on mute. Hey, Nato, thank you very much. That was a really great session. Super interesting, super exciting. So,
Thank you.
what happened to the DBAs? Where have they gone?
Some of them are still out there, hiding and helping organizations close the gap. But they had to, of course, on relational databases, when they are widely used, there are still DBAs out there. And some of them have updated their capabilities to the distributed systems, and then they are the ones closing the gap I was talking about. But a lot of organizations who started without the knowledge, because when you work with open source, and at some point it became an aspiration for the developers to be the ops themselves. So you just install Spark and you start running it, and it's really easy, not really easy, it's not easy at all, and you do it yourself and you're not aware of the gap. And as you use it more and more, the complexity hits you. And then you realize that there are missing pieces between the capabilities of whoever you are that decided to start using it and the needs of the organization. So I think it's kind of a fashion not to have a DBA, not a thought-through decision, let's just kill the profession.
So you think there will be a sort of replacement for them, or like the new version, the next version of the DBA, something similar to what happened with sysadmin role, right? That sort of transformed into DevOps, which is a little different, maybe a bit more complex practice. So do you think something similar would happen in the DataOps space?
So yeah, I'm pretty sure, and it really depends on the paradigm that you choose for managing data. So there's a new paradigm that has a lot of talk around it called the data mesh. So if you look at the data mesh concept, you would be talking about having the ops team or the infrastructure team providing only a self-serving infrastructure, while the knowledge about the data and hence the DBAing of the data would be done by the data engineers. And other paradigms are actually building data infrastructure teams that include not only the infrastructure itself, but also the knowledge of the data structuring and actually the DBA role, which requires from those people to have a very strong business context. So you have ops people with business context. It's a very unique requirement, but it does exist, and some organizations take this path.
Definitely makes sense. So let's touch a bit about data and data versioning. So right, many organizations are doing data versioning within the application itself, right? So how do you see that being happening in moving forward?
So data is an asset of the entire organization, and as you evolve, a lot of data sets that were once used only by one application for analysis are being used for many applications in different ways. So you should be pushing down the data versioning to an infrastructure level, to something that is horizontal and covers the data, rather than having it as something vertical that is used only by one application. Because if then you use another application, whether it offers data versioning or not, you cannot be efficiently communicating with the versioning of another application. The language is different, the API is different. It would become a mess going forward. But if the versioning is a quality of the data itself, then it's very easy to use it on all applications, which is what in the last slide was the right-hand side. The formats and LakeFS.
Interesting. And so you decided to make a Treeverse, am I saying that correctly? Treeverse, thank you.
Treeverse. It's a tree because Git is like Merkle trees, so we said tree. And then we thought about traversing a tree, you go over a tree. And then it became Treeverse, and there was no going back.
Once you go there. So you decided to make it an open source project. Like how did that come about? Obviously, as a startup, it's really hard to make that decision, I guess. So super interested in hearing the thoughts and the process behind that.
Yeah. So LakeFS is the project itself is called LakeFS, and it's open source because the ecosystem is open source. So when you look at big data infrastructure, it's open source. And the adoption of big data infrastructure is usually done by open source users and open source communities, because you need first to have the data developers believe in the product and help you shape it. And then you get the right product out there. And then the business model is what is called an open core model, where over this open source, which will always be an open source, in our case, we think of LakeFS as Git. So Git will always be open source. And we will be building over it a GitHub, which would have more enterprise features and manageability features over it that would be paid. But LakeFS, as it is, and a lot more that we're going to add to it, is going to stay open source. That would give us the penetration, the adoption, and of course, the great feedback and assistance of a community, which is the most important leverage you get from having open source.
Mm-hmm. And obviously, that's a downloadable software. And as we move forward, obviously, there are many as-a-service products that you can use out there. So how do you see this space being evolved? Do you see like the DataOps people mostly using something they would be deploying and owning, or do you see that going forward with a bunch of cloud services that are being available to them and they would be using them? Like, how do you see this space being evolved?
So it really depends on the industry. If you are a cloud user, then yes, you would probably be shifting to the cloud services, because the overhead in cost is not big if you consider the work that you need to do. If you compare it to the cost of people who need to actually run the systems locally, or on the cloud instead of using the cloud services. So yes, I think most organizations using cloud would be moving to the cloud services. Still, because cloud services offer so many options that overlap in so many ways. So choosing the right set of tools and then managing these tools synchronized would still be a DevOps effort that people would have to, that DataOps people would have to deal with. And I don't suspect it's going to be easy. I talked a little within the presentation about the different forces pulling this industry in different directions. And this would still pose a challenge for anyone who wants to build an optimal system for their needs.
Mm-hmm. Yeah. And so you talked a little bit about costs. Can you share any like war story about costs and managing data at scale?
I guess those would be just, we were hosted on AWS, so I think that would just be stories about cost visibility on AWS, where if you're not very careful and you have not tagged everything and you don't have the right, I'd say, standardization within the organization to constantly track your cost, when you are running so large distributed systems, then you would be hit by stuff staying up that you didn't know of, that could cost a lot of money, or even S3 costs that just, although S3 is very cheap if you have a lot of data, it is not cheap anymore. And if data is constantly duplicated, you would be finding yourself paying for those duplications, and suddenly it's hundreds of thousands of dollars a year because of the mess that you were running over your data. But I guess if you have visibility, this is solved. LakeFS solves some of that by providing visibility over the data. And over the compute, it's for AWS to provide this visibility and ease of management. I think they're doing better than they did 5 years ago, and should probably be doing much better. About other cloud providers, I know less of how it's managed, but I suspect it's similar.
Yeah, I've heard so many war stories of companies going and standing up new cloud projects and then suddenly receiving the bill for the first month, being like so surprised. I've heard this story so many times.
You need to establish standardization over cost tracking day one.
Yeah, definitely. All right, Einat, thank you very much. That's been super interesting. Thank you very much for the interesting talk.
Thank you for having me. It's a pleasure.